We wanted a human-safe robot, but without an air compressor. We really wanted the robot to be able to dramatically change its shape, like Transformers. The robot is essentially made of a set of these roller modules. It's actually very easy to take out the tube, route the tube in a different way, and create an entirely different robot.
We think about, some of the animals in the world. Interesting example is the octopus. In addition to being able to, use its 8 limbs to manipulate things, actually can change its overall body shape and fit through really small areas.
I think this research really highlights how to design and build robots in new ways.
This is a human-scale soft robot that's untethered, so that's what kind of makes it unique.
Thinking about using air instead of electricity, using materials that aren't ones that you would normally put into robotic devices.
So we took a big tube, we filled it with air, and then we actuated the robot not by pumping air in and out, but by having these little robots that essentially drive along the tube, changing its shape.
The structure of the robot is made of fabric, kind of like a t-shirt. The only difference is that it's also airtight. But like your shirt, the fabric is actually flexible when it's not inflated. But when it is inflated, it becomes significantly more rigid. We utilize this ability to sometimes be rigid and to sometimes be flexible.
It can actually move from one location to another.
The first time we took it outside and had it rolling around outside of the lab was a really exciting moment. It's one thing to make a robot work inside an engineered and kind of perfect laboratory environment, but to get it to work outside is a whole nother level.
A lot of robots will have like a gripper or something on them that can pick something up, but with its body basically it can engulf a basketball, pick it up, and then move it around in its grip, which is again something that's relatively challenging for robots to do with dexterous manipulation.
To operate untethered from any sort of power or pressure source could allow it to go out and really adapt to tasks that you might not have been able to predict.
Thinking about, things like search and rescue.
Say there's a certain tunnel it needs to climb through or an obstacle it needs to roll over, the robot can dynamically change its shape to account for these changing environments. Another application that we're especially excited about is using a robot like this for space exploration.
It's actually very small. It can just be crumpled up into a small volume.
And potentially put it onto a rocket, flies to some other place in the solar system.
Like Mars, for example, and then once it's there, deploy by inflating and then operate untethered to any compressed air source. Using its shape-changing ability, traverse kind of complicated environments.
Some of the things that we're looking at in the near future are thinking about new configurations of this robot. Right now, we just have this one octahedron configuration. What are different ways that we might combine these nodes together to create different shapes that could allow us to do different types of tasks?
For more, please visit us at stanford.edu.